Hello world, this is my first video in this channel and I shall be covering all the topics of the book Feynman Lectures on Physics Volume 2, mainly electromagnetism and matter. We shall be starting with the second chapter, which is Differential Calculus of Vector Fields, because it covers necessary mathematics that we would be using frequently. An introduction. In order to understand Maxwell equations of electrodynamics, we need a thorough knowledge of vector calculus and differential equations. It is necessary that we understand the behavior of solutions with its physical significance. Dealing with complicated situations and converting higher dimensional equations to lower dimensional equations that we would see in the upcoming future lectures. Some pre-required knowledge. What is a scalar and vector function? Some basic vectorial properties like A dot B dot product, A cross B cross product, A cross A equals 0 because A cross A contains a sine theta term and sine 0 equals 0. A dot A cross B equals 0. A dot B cross C equals A cross B dot C. A cross B cross C equals B A dot C minus C A dot B, which is triple cross product. Applying partial derivatives to a function. Some differential properties for continuous functions like del square f upon del x del y equals del square f upon del y del x, which is essentially only applicable for continuous functions, and some properties about exact differential equations. We would be taking up the next topic in the next lecture, which is scalar and vector fields. If you have any queries, please do notify in the comment section. Like and subscribe, and thanks for watching.